Alright, I'm not going to do very many of these since most of them follow the same pattern that we discussed in class, but I did want to put together a real quick video just to refresh you of what that pattern was. So let's look at number 1. You're making an ice cream cone with chocolate, strawberry, vanilla, or mint ice cream on a waffle or sugar cone. And we are to create a tree diagram to represent each situation. So since I could pick any of those 4 ice cream flavors, and I could pick either of the 2 cone types, that presents me with a number of combinations that would accurately depict or represent this situation. So I'm going to start with the ice cream flavors. So I have chocolate, I have strawberry, I have vanilla, and I have mint. And each of those 4 flavors could go on either type of cone. So from each flavor, I will have waffle cone or a sugar cone. And so remember in class that I did tell you, you need to list your possibilities. So it should be pretty clear from here that we're going to have 1, 2, 3, 4, 5, 6, 7, 8 possibilities. So I have chocolate on a waffle cone. I have chocolate on a sugar cone. And I'm fine with abbreviating as long as you can abbreviate something that makes sense to me. I want to know that you have a good solid understanding of what this tree diagram represents. So I have strawberry on a waffle cone. I have strawberry on a sugar cone. I have vanilla on a waffle cone. I have vanilla on a sugar cone. And I have mint on a waffle cone, and I have mint on a sugar cone. So those would be my 8 possible permutations that represent this particular situation. Now, since we can count these up, that makes the obvious answer over here 8. But remember that we want to be able to figure this out mathematically using our counting principle. Counting principle does not mean that I do the tree diagram and then count the possible permutations. Rather, it means I recognize that I have 4 different flavors of chocolate. That's my one possible outcome. And I multiply it by my second possible scenario, which is the waffle cone or the sugar cone. So times 2 equals 8 possible permutations. Let me do one more just to refresh your memory, and this one should be straight in your notes, which is why I'm going to go ahead and do it, because I can walk you through it a little more slowly, and you can watch the video to refresh yourself on how it's done. 3 coins are flipped. Well, we know the coins each have the option of heads or tails. And so that would be my first flip. And on the second flip, I could get a heads or a tails. So thus far, my options are, I could get a heads on the first flip, a heads on the second flip. I could get a heads on the first flip, a tails on the second flip. I could get a tails on the first flip, a heads on the second flip. Or I could get a tails on the first flip and a tails on the second flip. But now we want to add in a third flip. And as you can see, you will probably want to be very careful to make sure you give yourself a lot of room, because I probably should have expanded out my second flip a little bit more, spaced it out so that I had more room to fit all these in. But I can see from my third flip, which gives my total number of permutations, that I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 permutations. So I'm going to start to list them. Heads, heads, heads is my first option. My second option would be heads, heads, tails. My third option would be heads, tails, heads. Or heads, tails, tails. My fifth option would be tails, heads, heads. My sixth option, tails, heads, tails. My seventh option, tails, tails, heads. And my last option, tails, tails, tails. And so from this, we should gather that my first flip has 2 sample spaces. My second flip also has 2 sample places. And if I were to cover up my third flip, you could see that I would have 4 possible permutations. So 2 times 2 is 4. Well, in this particular instance, we need to add one more variable because we're going to multiply it by the sample space of our third flip. So 2 times 2 is 4 times 2 equals 8. They in fact match. We have 8 permutations that we listed using our tree diagram, and our counting principle now matched that same solution. That should give you enough to get a sufficient start on the remainder of your homework. Again, make sure that you show all of your work. Have a good evening.